into 100. What we have? Mass of solute, it is 2 gram. We will write here 2 gram. Mass of solute here is 2 gram. Mass of the solvent we have 18 gram. Here what we have? Mass of solution. Mass of solution, it includes solute together with the solvent into 100. What we have? 2 gram by what is this? 20 into 100. We have 10% W by W. This is how we can represent the percentage W by W. Let us discuss the next quantity which is used to represent the concentration in the solution is termed as mole fraction. Mole fraction, it is quite simple, but we have to care about the moles. Mole fraction, it means it is the ratio of number of moles of a particular component to that of the total number of moles of different component in the solution. Let us understand it. Mole fraction. Mole fraction, I have told you that mole fraction, it is represented by X, and I have stated that mole fraction is the ratio of number of moles of a particular component. Mole fraction is the ratio of number of moles of a particular component to that of total number of moles of different components in the solution. Mole fraction X is X, it means mole fraction of a particular component. That is equals to what? Mole fraction of particular component is equals to number of moles of particular component divided by total number of moles in solution. This will be more clear to you if we take binary solution. That means let us understand it by taking an example of binary solution. Let us have binary solution. You know binary solution, as the name indicates. Bi means 2. That means binary means a solution having 2 components. This will be, mole fraction will be more clear to you if we take binary solution. Let us have a binary solution in which one component is A and the other is B. If we suppose a binary solution, and suppose one component to be A and another component to be B, then in that case, how we will represent the mole fraction? It can be represented as A, that is mole fraction of A. It is equals to NA by NA plus NB, where NA is number of moles of A, where NB is number of moles of B. It means if we have a binary mixtures, then the mole fraction of A is represented as XA is equals to NA by NA plus NB. This NA is the number of moles of a particular component, that is A, and divided by total number of moles of the solution. Total number of moles means if we have two components, then the total number of moles is equals to Na plus Nb. Na stands for number of moles of A and Nb stands for number of moles of B. If we want to get the mole fraction of B, then we represent it as XB is equals to NB by NA plus NB, where this NB we know number of moles of B and A means number of moles of A. This is how we can know what is the mole fraction of V, what is the mole fraction of B. The next thing is that if we have a binary mixtures and we have the mole fraction of A and mole fraction of B, when we add the mole fraction of different component, if it has two components, if we add up XA plus XB, then it is equals to 1. What we have, one more thing is that when we add up, here I will write it, when we add up the mole fraction of different component in the solution, we have 1. It means here what we have here, if we add up XA plus XB, it is equals to 1. But if it has a large number of components, it means it is not a binary mixture. Then in that case, XA plus XB plus and so on plus XN equals to 1. We have the relation. If it is a binary mixture, then in order to get XA, what we do? If we have the mole fraction of B, then we will minus the mole fraction of B from 1. Then we will got XA. This is how we have studied the mole fraction, the ratio of number of moles of particular component to that of total number of moles of different component in the solution. We have also discussed when we add up the mole fraction of different component, then in the solution we have 1. as we have stated by taking various examples. We will discuss the next quantity, that is molarity. Molarity, it is represented by capital M. Molarity, it means it is the most widely used quantity in chemistry. It is represented by capital M and defined as the number of moles of solute in 1 liter of solution. Clear? Solution, it means it includes both the solute together with the solvent. What we have, it is defined as the number of moles of solute is defined as the number of moles of solute in 1 liter of solution. How we are going to represent molarity? This equals to number of moles of solute divided by what? Volume of divided by volume of solution in liter. Clear? To the next, we have the number of moles of solute is equals to what? W. W, it means the mass of the solute divided by molecular mass of the solute. When we divide the mass by molecular mass, then we will got the number of moles of solute. The next one, if we have the volume of solution in ml, then we will divide it by 1000, then we will got in liter. Then what we have the relation? It is equals to W2 acidity of solute by M2 into V into 1000. What we have? W, it means the mass of the solute. M means the molecular mass of solute. What we have? VML, it means volume in milliliter. And what we have the equation? Molarity. M is equals to W2 by M2 into 1000 by V. This is all about the molarity. So the next one, what we know? Molarity is only the quantity that is affected by temperature. Why? Because it contains volume. When temperature increases, then volume increases. When volume increases, then the concentration decreases. What we have? It is the quantity that is affected by temperature. What is in units? Its unit is what? We have the number of moles, that means moles per liter is moles per liter, that is, or moles liter minus 1. This is about the molarity what we have studied. We will discuss the next quantity, that is molarity. It is represented by small m, and molality can be defined as the number of moles of solute in per kg of solvent, not the solution. It means it is defined as the number of moles of solute, in per kg of solvent. I have written here solvent, not the solution. How we are going to represent? It is going to represent like this. M is equals to number of moles of solute by what? Divided by per kg of solvent. Mass of solvent, that is 1 kg. You can simplify it. Number of moles of solute, I have told you. One relation we have, I have told. Number of moles of solute, that is equals to what? Mass of the solute divided by molar mass. Is represented as number of moles, and it is represented by W by M. I will write it here. Number of moles of solute, it is represented by W by M, molar mass. Mass of solvent in kg. Mass of solvent will take, if it was W2, then that will be in W1. Solvent in kg, if it is in gram, then we will divide it by 1000. What we have? We have W2 by M2 into W1 by 1000. We have the relation where W2 is mass of solute, W1 is mass of solvent in gram, solute in gram. We have the relation, and this is all about the first chapter which we have studied. We have discussed today the various quantities which is used to represent the concentration in solution state. Why it is necessary? Because we carried most of the solution, most of the chemical reaction in solution state. How to represent? We have discussed that it is represented by mass percentage, it is represented by mass by volume percentage, it is represented by volume percentage, it is represented by parts per million, it is represented by mole fraction, it is represented by molarity, it is represented by molality, it is represented by normality. But in this class we have discussed few of them which you have studied, that is molarity, mole fraction, mass percentage, which will help you to determine the concentration of solute in a solvent.